All right, welcome back to Boyd Book Club. Today we are tackling the second part of Chapter 4 of Osinga's Science, Strategy, and War, finishing up this idea of completing the shift in Boyd's thinking. So today we are going to focus on chaos and complexity theory and this concept of complex adaptive systems that we didn't really get to in Part 1. As we begin talking about chaos and complexity, we are going to be talking extensively about systems and how systems function. We're going to break down three types of systems: isolated, closed, and open systems. And open versus closed systems are going to become sort of the most important as we think about chaos and complexity and how they apply to Boyd's strategic thinking. What we are talking about in looking at systems is whether or not the system has an interaction with the environment. Two principal ways in which systems can interact with their environment is through the exchange of energy and the exchange of matter. Energy is illustrated by the red arrows. Matter is illustrated by the blue arrows. What we are concerned with is the flow of energy and matter in and out of the system. So, let's discuss isolated systems first. Isolated systems I choose to represent by using a very popular cooler brand that is known for its ability to keep ice for a long period of time. So, conceptually, in an isolated system, no energy enters or leaves the system, no matter enters or leaves the system. In a more practical physical realm, we could also consider a rock an isolated system. Rocks just sit there. And yes, while they will absorb some radiation from the sun, if you were to put a rock into a vacuum, that would be a truly isolated system. But I think for the purposes of common understanding, using the cooler example is a good one. And we can recognize how isolated a system is by how quickly that ice in there is melting. So, isolated systems give way to closed systems. Closed systems allow for energy to be transferred both in and out, but they do not allow for matter to be transferred in or out. So this type of system, right, we've got an example here is the biosphere dome. And the biosphere domes are those that have been created to experiment with the idea of self-sustaining habitats. This is particularly interesting for folks looking at the options for long-term space travel. When we look at the biosphere concept here as a model of a closed system, what we're looking at is a system in which all matter is contained within it and does not leave the system. With biosphere, what it is using is all of the organic material, the plant life, all the living organisms inside the structure to create a self-sustaining system. A biosphere is essentially just a terrarium in which all of the plant life creates its own moisture, creates oxygen, uses up carbon dioxide, and all of these things operate as effectively a waste-neutral system. However, they are still being processed. They are still being furthered by the input of energy and the outflow of waste energy. So closed systems take in productive energy, do work inside the system, and then release unusable energy in the form of waste, but do not release any form of usable matter or work. An open system, in contrast, is like our plant. So within the biosphere, within the closed system, we have open systems that are taking in energy, taking in matter, processing them, and then releasing energy and releasing matter. These are items, open systems are those that are doing work and engaged with the environment. When we discuss these systems, we also want to discuss whether or not these systems are capable of self-organizing behavior. Open systems, also known as dissipative structures, are self-organizing. Closed systems are not self-organizing. They display disorganized entropic behavior. So we can contrast the open system of a hurricane or cyclone with the closed system of the damage left behind by that same process. So when we look at our hurricane, our cyclone, our open system with its dissipative nature, what we are looking for is a pattern in which energy coalesces to form a functioning, organized system. It may be chaotic, but it is still doing useful work and organizing itself. Now, what we see as we watch a hurricane, as we watch a cyclone, as we watch a tornado form, is that disparate bits of energy find an attraction point and begin cycling, condensing, and then spiraling back out. The eye of the hurricane can be considered an attraction point or an attractor. The attractor in the open system allows for this energy to become self-organizing. Conversely, in the closed entropic system, all this energy does not get put to productive work. Rather, it leads to disordered conditions. So, it is unlikely that this pile of debris here would perform any self-organizing action and form itself into a useful structure, into a dissipative structure, an organized structure. That pile of debris is going to lie there. This cyclone is an open, living system, for lack of a better term. Our pile of debris is a closed, dead system. Some other key points that we want to consider when we discuss chaos and complexity theory, and again, thinking about how these will then apply to Boyd's thinking, is that chaotic systems are dynamical. They are deterministic, meaning that given a certain set of initial conditions, a certain set of outcomes will be obtained. However, deterministic does not mean that they are predictable because they exhibit nonlinearity. Complex, large systems that are chaotic exhibit unstable, aperiodic behavior in deterministic but nonlinear ways. So this definition by Stephen Keller, there is some dispute about its wholesale validity as a definition of chaotic systems, but I think it is a very valuable one, and it exhibits many of the behaviors of chaotic systems. Or I should say it describes many of the behaviors of chaotic systems, right? Unstable, chaotic systems emerge at points of disequilibrium. When we have an equilibrium, we do not have a chaotic system. We have a system in equilibrium. A system in equilibrium would be your coffee cup that has released all of its energy into the room atmosphere and done no productive work. The coffee cup and the room are at a common temperature. In an unstable, aperiodic, meaning we cannot predict the repetition or the period in which process will occur. So unstable, aperiodic behavior in deterministic, so a set of initial conditions will still lead to a set of outcomes, a specific set of outcomes, nonlinear systems, okay? So linear systems are those that track a particular point as time changes, for instance, distance changes. And we can take snapshots of a linear system and predict its ongoing behavior over time. This is what linear regression is all about when we study statistics, geometry, things like this. We use linearity to predict future behavior. So if at time 0, I begin my observations. At time x, I see this. At time x1, I see this. At time x2, I see this. I can predict with some degree of accuracy, based upon my line of regression, that at time x3, I will see this behavior. Linear systems are predictable. Nonlinear systems, however, are not predictable. So in this case, at x, we are here. At x1, we've reached this point. At x2, we may not have reached the same point that we would have in our linear model. But more importantly, in our nonlinear model, we cannot conduct predictive or regressive understanding of what is happening in the system. Our linear system can be diagnosed by this line of regression, and our nonlinear system cannot. We cannot predict where the system has been between any two observable points. All we can say is that given a specific determination of initial conditions, that we will obtain a specific outcome. We cannot necessarily predict based upon this line where we will go. And if we take this nonlinear system over the course of a long period of time, we decrease our ability to predict any sort of possible outcome and find rather a range of potential outcomes where this nonlinear system may end up. This brings us back to our complex adaptive structures that we begin discussing in part 1, how the OODA loop describes complex adaptive structures, right? So some qualities of complex adaptive structures that are particularly useful for consideration as we look at the OODA loop, Boyd's thinking in general, his strategic philosophies, things like that. First off, complex adaptive structures, organizationally closed, structurally open. What does this mean? We are organizationally closed. This model is a bounded system. It is a boundaried system which does not change its process based upon the interaction with its environment, but it is structurally open, meaning that it allows for inputs to bring energy into the system. Okay? So with the OODA loop, we have unfolding circumstances, outside information, and our unfolding interaction with the environment all feeds into our observations. This feeds into our orientation. Our orientation both feeds our decision-making and action, but it also implicitly shapes our observations and implicitly guides our actions. This is where structurally open comes in. Physical and informational interaction with the environment is an aspect of complex adaptive structures. We see physical and informational interaction in the structurally open method of the OODA loop. Non-predictable due to scale and nonlinearity. So complex adaptive structures are non-predictable due to variations in scale and nonlinearity. So how can we think of this? We can think of this in terms of group behavior, right? Also sometimes known as mob mentality. Each individual agent within the larger structure may have its own level of somewhat predictable behavior. Its scale is small enough that it may behave in a moderately predictable way. But with the synthesis that occurs in a larger cohesion of individual agents or individual organisms, we see an increase in nonlinearity as the variance, as the unpredictability, as the indeterminacy within this coalesced complex system comes together. There's a lot going on here, and the reality is that a deep understanding and grasp of chaos and complexity theory is somewhat beyond us and somewhat beyond our project here in studying Osinga in particular, but it is something that we need to have a foundation in. The last aspect of complex adaptive structures that really applies to Boyd is this notion that they display historic and evolutionary qualities. So if we think about society as a complex adaptive structure, we see that societies have historic epochs, periods of time that they have gone through, and that they have had an evolutionary process. What's important to remember when we discuss evolutionary processes is that evolution does not equal betterment. Evolution is synonymous with change over time. It is not a measure of quote-unquote progress. It is not a measure of reaching a idealistic end state. It is simply the adaptation of the organism or the group of organisms or the complex adaptive structure to increase its fitness to its environment. This is an important point to come back to again and again and again. Evolution is different than quote-unquote progress in the human notion of progress as the ever-expanding improvement of society and individuals. That's not what evolution is. Evolution is simply change over time. So as we finish up chapter 4 in Osinga, we need to consider a few different things. We need to consider how Boyd's thinking is shaped by this scientific zeitgeist of the time, of the changing understandings of knowledge, of physics, of systems thinking that occurs from his time flying fighters over Korea in the 1950s through the end of his study and his last cohesive works in 1995. During this time period, much occurs in this changing zeitgeist, this changing understanding of the universe around us. And uncertainty, nonlinearity, chaos theory, and similar concepts all offer Boyd a set of metaphors to examine the patterns of conflict that he has considered, that he has seen, and give him a way of expanding upon the strategic thinking in his own military experience to synthesize a new view of warfare, but also a view of human thinking that can enable us to look at the world in a critical postmodern light. All of this is going to be important foundational understandings as we continue to explore Boyd's ideas and how we can apply them. As always, thanks for taking some time out of your day to join me and participate in this discussion. I want to say a special thank you to the Patreons who have made this possible by throwing a few bucks in the hat and helping support this work. Please like, share, subscribe, let other people know what we're doing. Participate in the Instagram discussions, participate in the conversations on Facebook, jump down in the comments and participate in the discussion on Boyd and his work.